Alright, so this will be the second day of the law of sines. Pretty much the same thing with one small exception. Actually, it's a pretty big exception, so pay attention. So this is, again, Unit 8, Day 2. So here's what's happening. Looks the same as before. They ask us to draw a side A opposite angle A that's 6 units long. So I do that. We have an angle A and side A that we know, so that's going to be our key fraction. We know the side, we know the angle. And since we know side B, which is going to be opposite angle B, we can find angle B. So we cross multiply, solve for sine B, remembering that we have the value for sine. To get the angle, we do inverse sine. Let me do that on the calculator just for practice. So let's first start here. We have 4.8 sine 45 divided by 6. Enter. And then to get the angle that has that sine, we do second sine, go up to that value, press enter, and if we do inverse sine, we get the angle, rounded to 3 decimal places. Now in part B, we have something very silly. If you think about it, this is up 48 or 4.8 at a 45-degree angle, and then side A is only going to be 2. If I draw it to scale, you see the problem? This is not going to reach this line down here. And so it's an impossible situation where the numbers they gave me are ridiculous. But let's say you didn't know that. You just drew it not to scale, fill stuff in, and here's what would happen. Again, we have an angle and the opposite side given to us. We just take it at face value. We're given side B. We don't know angle B. We cross multiply. We divide by 2 to get the sine by itself. And we get a sine value of 1.697 or so. And that should raise a red flag to you. The sine values have to be between -1 and +1. Remember the sine curve? Up 1, down 1? This is past that. It's past the range of sine. It's an error. If you didn't notice that when you did the inverse sine on your calculator, it would say error. Let me show you. So let me start here. We have 4.8 sine 45 degrees, and then divide that by 2, and we get the sine value. You're thinking nothing of it. Second sine, and then you go up to that value, and you get the angle, and it says wrong. But if we're given an angle and 2 sides, side-side angle in geometry did not exist, because given 2 sides and an angle not included does not give you a unique triangle. Things can happen, and that's what happens in C. Notice that they want the side opposite 45 degrees to be 4. Well, to scale, opposite 45 degrees could have been here at 4, or could have been here, because I can change the angle but yet have both of these segments be the same length if it's just right. In this case, it is. Okay? So again, we have the complete fraction, side A, angle A. We know the side B, looking for angle B, cross multiply, get sine B by itself. Here's our value for sine. The inverse sine gives us this. But look at the geometry of this. Angle B could be this one, which is opposite this side. Well, since these two sides are the same, this triangle is isosceles. And so this angle and this angle are the same. This is a straight or 180-degree angle. This makes up the other part of the 180. Look at this triangle. Do you see that it also has the same angle A, the same side A, the same side B, and this could be the other angle B. Two possible triangles. The green outside triangle and the blue inside triangle. They both have the same 45 degrees, the same 4.8, and the same 4 here and here. What a mess. But here's our angle B that we found. If we take 180 minus from that, I'll get the other possible angle in this case. So here's what I am suggesting. Always assume the ambiguous case. The third angle will either be 180 minus the angle you just found minus theta, or 180 minus the angle you just found and 180 minus theta. I'll show you what that means later. If they're both positive, you have the ambiguous case. If the second one is negative, you don't. Again, we can talk about it, but I'd rather just show you.